this session, we have two speakers from Microsoft. The first one is Sadid Hasan, and he will be talking about evolution of generative AI. And his speech is going to be on understanding the decades long journey of AI that has led us to recent emergence of generative AI. It is important to make the best use of its current capabilities and shape its future potential. This talk will focus on connecting the dots between the past, present, and the evolving future of generative AI. Let's have a round of applause for Sadid Hasan, who is joining us online. You can share your screen now.
Yeah, thanks, Muskan. Hope you can all see my screen. All right, can you hear me? I can't hear you, but I assume you hear me. Okay.
Yes, yes, we can hear you, yes.
All right. Yeah, so in this talk, I'm gonna talk a little bit about how we can connect the past, present, and future of generative AI. So I'm AI lead Microsoft. I've been working in AI research and product development for about 2 decades, and currently I'm leading the development of generative AI capabilities and solutions for Office M365 Copilots and Azure AIOps products as part of Microsoft's Advanced AI Development and Acceleration Program, and we are based in the New England Research and Development Center in Cambridge, Massachusetts. Before Microsoft, I was an executive director of AI at CVS Health, and before that, as the technical lead of Philips Research AI Group. I studied NLP and Machine Learning in my PhD and have lots of publications and patents in this area. So feel free to connect with me in LinkedIn for more details. So let's jump into today's session. So as you have been, hearing today from all sessions that you're attending, so generative AI is transforming how we approach work and creativity and collaboration. So this is kind of making an impact in several industries that we are familiar with. So for example, in tech industry, we can see use cases where we want to enhance the user experience. So many of the products that we are building, the copilots in Office M365. So how can we improve our user experiences? How can we improve recommendation systems to improve the search so we can have a chat-based experience? How can we improve software development experience? So, we have GitHub Copilot for that. So similarly, in other industries like finance and banking, we can have risk mitigation strategies, predictive analytics solutions. For healthcare, I have about a decade of experience in healthcare domain. It's pretty challenging and unique and also very impactful in terms of predictive analytics, personalized medicine, precision medicine, drug discovery based use cases. For education industry, it's also very impactful, generative AI, in terms of personalized learning experiences. So in terms of both helping our students to learn more using generative AI based examples and curriculum, as well as for the educators, the teachers, for content generation and assessment of students' learning capabilities. We also have, if you see other industries, for example, in consumer and retail and manufacturing, so where the AI development has started at the beginning in terms of how we can personalize experiences, product-based recommendations. So many product recommendations, as you have seen, for example, in Amazon, eBay, Netflix, all those different product recommendation systems are based on this. And we also see use cases of generative AI in creative and gaming industry in terms of content generation, new environment creation, and scenario creation for different type of game users and also characters. So this is the slide I actually want to use to connect the dots between the past, present, and future. So yeah, since I don't have much time today, so I'll see if I can go through this quickly. So these are the milestones in technology, data, and AI revolution, so you can understand why we are here now seeing the emergence of generative AI. So we can go back to history thousands of years, but starting from 1440s, of course, the invention of printing press, that actually was very impactful in disseminating the knowledge and in terms of figuring out how people can express their knowledge in terms of books and in terms of going to the libraries. So that is one of the first ways when people started to share their knowledge and best practices through the printing press technologies. At that time, what happened is that some Ottoman empires in Turkey, they were actually trying to prevent this progress, and they thought that, okay, if knowledge is disseminated, right, then others would be able to learn more and take care of their emperor. So that's one of the ways they were falling back in terms of technology and progress in the literature and knowledge sharing, and the other parts of Europe actually grown themselves through the use of that technology. So that tells us that preventing the technologies with some fear of some risk and gain balance and analogies, sometimes that might hold us back in terms of compared to how we can embrace the technology more to learn from it and use it for our benefits. So first, for 400 years, when the computers were invented by Charles Babbage and his intern Ada Lovelace, she wrote the first program, which is kind of a logical analysis of some of the documents that she was writing. But at that time, it was not really appreciated because people thought that, and even Charles Babbage thought that this is too into the future, too much logical progression may not be needed in terms of the analysis engine. They're trying to really use computers as basic computational, like what we have seen later on in calculations and calculators. Fast forward, about 100 years, we have seen, from large machines that the computers were in huge rooms. The revolution started how we can get personalized computers to everyone's desk. So that's where Microsoft started its journey. The operating system came into being. The PC revolution started with Microsoft and some other companies. And around that time also, if you see, the AI and machine learning progress also started. And that time in Dartmouth College in Massachusetts, the first time the artificial intelligence term was coined by John McCarthy. And at that time, people started to really define what it means to teach machines and really understand that how, or if at all, can machines mimic how humans think, act, or do things rationally. So that's when people started to define AI and try to understand and define rules based systems. Expert systems started. There is symbolic learning and machine learning also. The term was coined at that time to learn things from data, patterns from data, in a way that there is a metric and the machines can actually improve over time their learning through the data, and the metrics can be useful to measure their learning capabilities. But there was also ups and downs during this time. There was different type of deep learning based, neural network based machine learning algorithms were proposed, but due to lack of capacity in machines and computational capacities, lack of data at that time, there was a pause in AI progress. We call it as AI winter. But around that time in 1990s, when internet revolution started, then we have seen huge amount of data collection started. People have been starting their own website, sharing of knowledge through the web. That was the start of data revolution and connectivity revolution. And that is something that started again, the AI summer, and things started popping up. People started doing more experiments with the data that they have, but still the lack of computational capacities were there at that time. But then IBM came up with the Deep Blue, the chess algorithm that showed that it can actually beat humans. So that was one revolution, a revolutionary moment, milestones in AI that kept people thinking that really there are machines that can actually think and even outthink humans in terms of games like chess. In 2000s, we have seen the rise of social media platforms like Facebook, LinkedIn, Twitter, Quora, that also enhanced the collaboration between humans in terms of data sharing. And in 2002, there is that breakthrough came about how can we go from individual machines, right, at our desks to really improve the storage systems where we can all collaborate together in the cloud, where you don't really need specific storage or fixed storage at a time. You can actually allocate resources based on the needs and based on whatever you want to do, what kind of applications you want to use. So that cloud computing accelerated our computational capacity, and that also revolutionized some of the AI algorithms and neural network and deep learning algorithms later on. And around that time when iPhone started, so that also gave us another milestone in technology where people now have phones in their pockets. So in a way, right now we can't live without iPhone and smartphones. So So that also played a huge role in data sharing and computation. In 2011, IBM Watson again came up with the award-winning Jeopardy competition win, where they beat the humans during that competition in question answering tasks. So that showed that huge amount of connectivity between knowledge bases can also help figuring out the answers to complex questions, and even vice versa, generating questions to complex answers. So that also is a huge milestone in AI. And around that time in 2012, then deep learning revolution started, and this is the time when I was in my grad school, where we had ImageNet dataset came out, convolutional neural networks were applied in object recognition tasks. So at that point, people started to see really the benefit of computer vision technologies, and found that recognizing object is not easy as it is as humans can do, but still it can be taught to the machines to even outperform humans. And during the next decade in 2013 and 2020s, there is tremendous progress in different types of machine learning algorithms. So for example, I proposed reinforcement learning for summarization, complex question answering formulation. Then there were also sequence to sequence modeling, encoder decoder based approach, recurrent neural networks were again reproposed for language tasks. Attention based models were used for language modeling. Transfer learning came also in terms of when you don't have much data for specific domains. So you train your algorithm in certain domain, and then you can reuse that learning to fine tune your model into some other domain. So that's the concept of transfer learning. Multitask learning also came during that time, where the idea was, can you actually use the same set of features and same set of embedding layers or weights that you have learned from certain tasks for performing some other tasks. And generative adversarial network came during that time. Transformers came, that's the backbone of large language models now. Embedding based language models, BART, GPT based models, all are progression of those different technologies in terms of sequential data modeling and language learning during that time. And that led us to the progress of various computer vision based stable diffusion models, DALL-E, ChatGPT, generative AI. So we call them foundational models because they can be now used for accomplishing different tasks at the same time. And in 2023, we have seen that the evolution and the generation of GPT-4 based models being shared, the copilots that we are building, leveraging GPT-4, GPT-4V, DALL-E 3. So things are going multimodal, as we have also talked about during the panel if you attended in the morning. So going towards multimodal data, and how we can leverage multiple domains, multiple languages, and multiple different types of inputs at the same time to really propagate the knowledge and understanding of the AI machines. So moving on, again, connecting some of the terminologies that we frequently use to ground our knowledge into these areas. So of course, AI is the broader umbrella term. Machine learning is a subfield. Deep learning is a subfield where we can learn and build algorithms layer by layer. And generative AI is even a subfield of that, where we can actually generate data in different types of formats, given the data is similar type of data is used in the input. And many times we have seen that same terminologies or different terminologies are used to represent AI and subfields. So, frequently we are now using large language models, foundation models, and large multimodal models. An overlapping term is data science. So that's kind of, to ground our knowledge into the terminologies. So I want you to focus on this slide about seeing that the evolving definition of complexity of AI. So when, in 1950s, the first definition of AI came, where people tried to say that, can machines think? So during that time, Turing test was trying to judge if a machine can actually fool the human judge into thinking that, is it really a machine or a human in the other side of the room, right? So that was kind of the test during that time. There was in 2012 in Winograd schema challenge in University of Toronto, professor, they proposed that this is actually too simple to fool the human judge or a test. It should be actually a common sense reasoning type of test if we want to define AI. So for example, given a sentence like this, the trophy wouldn't fit in the brown suitcase because it was too big. Is it really the trophy or the suitcase, what was too big. So that has to be understood by the AI model to really see that if that's, the machine is capable of thinking like human or not. So from that angle, you can see the definition of AI is really throughout the years have changed. So something people started with rule-based methods first. We have thermostats at our home that basically rule-based, and from rule-based towards machine learning-based systems, from discriminative to generative systems. So for example, entity recognition tasks, those are discriminative. Classification tasks, from classification to generative tasks, and also trying to combine different modalities in terms of how humans see, hear, read, think, reason, understand, write, smell. For each of these, we now have AI models. So you can see that throughout the history, what happened is if something was solved by AI or machines, then people started to consider that maybe that's not AI. So for example, right now, if you think about the deep blue or any chess algorithm, right, we might think, okay, it's too easy, it's not AI at all, right, because we have been familiar with this for a long time. Simple question answering machines, recommendation systems we use in our day-to-day life, but still we might feel that right now we take those AI systems as for granted and feel that, okay, maybe that's not really human level thinking. So we are actually evolving the definition and complexity of AI as we go on. And now our expectations are even huge due to ChatGPT and GPT-4 like powerful models. So if you focus on the journey of generative AI specifically, so in 2010, the near perfect machine translation, that was the the first thing that happened when we used the Bing Translate and Google Translate, translation between multiple different languages. So that was the first task people tried to solve. And then language models started in 2014, where people really understood that semi-supervised learning or self-supervised learning, where you don't need to have some levels, you can use the language itself by masking them or predicting the next sentence. That would give you some objective function that can be leveraged to understand the context and predicting the next words or phrases to define or do multiple tasks. So that led to the large language model and foundational models. And through that, ChatGPT gave us that simple way of accessing LLMs. So people, when they started accessing these tools, they realized that how powerful they are in a conversational type of setting. So the main benefit, what we have achieved through this, is that our ability to interact with this kind of models in natural language, right? So natural language became the new programming language. We don't have to really learn complex programming languages to teach what needs to be done. So natural language actually empowered everyone to use this kind of models to accomplish our tasks. So these are the verticals we already talked about in generative AI right now, in terms of the modalities, that text, image, audio, video, 3D code, all different modalities. Now it's possible to generate similar type of input through the foundational models. And this is kind of the vocabulary that we use right now. Large language models is model trained on vast amounts of text data, which you are all familiar with. Multimodal, it's understanding different multiple types of inputs and output at the same time. Foundational model can be trained on a diverse data set on multiple different types. Prompting is the new type of analogy that we use, the instructions, how can we get the best output from the LLM. So that's where lots of engineering happening right now to get the desired results. And also there are different types of prompting for that purposes that we use, like zero shot and few shot and chain of thought, graph of thought, prompt programming, and different type of ways that we can really leverage the power of the large language models.
Hi,
So this,
Sadid.
yeah, go ahead.
Sorry, we're running out of time, so I thought that I would. I think you're just left with 1 minute.
Yeah, sure. Yeah, I'm almost there. So this actually gave us the paradigm shift that, from task specific models to foundational models, that previously we had different tasks and different models that we had to build separately. And foundational models can actually be used for solving multiple tasks. And the real benefit actually is not coming from the language model. As we know, the language model gives us prediction of next words or phrases, but it's actually coming from these additional layers of on top of it, the supervised fine tuning and the reinforcement learning with human feedback, that is actually giving the boost of the making these models more powerful. And I'd like to end with this few slides where the main idea here is that the model, even if it is very powerful, it's not a product. We have to include lots of guardrails, responsible AI best practices for understanding the input, the user's intent, as well as the responses from the LLMs to make sure that these are useful models. And the key takeaways for today's presentation is that, of course, we are all building these solutions with the assumption that human feedback is a gold standard, but is actually not. So therefore, there are many papers I have, I'll share the slides, you can have a look, that is looking into how can we really improve the models, keeping in mind that these are not gold standards. So that's where progress happening in metrics and responsible AI best practices, removing hallucinations and things like that. We are also working on making the models smaller day by day and how we can do efficient fine tuning and training, better alignment with retrieval augmented generation methods, and how can we improve the accuracy and the guardrails, and also agent-based architecture. That's the future paradigm that we are working on, that how can we leverage all these LLMs and in a collaboration settings where these agent-based systems can talk to each other to solve complex tasks for us. Yeah, so I would like to end there. Thank you for your attention. If you have any questions, yeah, feel free.
Thank you, Sadid, for taking us on this wonderful journey of the